So this is the review video for the quiz on lessons 3.1 and 3.2 on solving linear systems. So every one of these equations, or pair of equations, their final answer is going to be a coordinate point with an x and a y coordinate. But you have four types of graphs that I can sort of foresee you having on the quiz. One of them would be like this first part right here, which I'm going to graph in blue. It's x equals -2. What that means is that this is a vertical line where x is -2. You can tell because this equation does not have a y in it, so it's not going to be a horizontal line, only a vertical. So put a vertical line where x is -2. If you're doing these correctly, you should be using a ruler, and you should try to make these as straight as possible, as accurately as possible. So we have a vertical line right here where x is -2. The other problem, that one in green, is set up for something called the intercepts method, which is usually a pretty easy thing to do and is easy to recognize because in this case we do have a y and an x and they are together. So you can go through and rearrange this and solve it like a y equals mx plus b and graph it that way. Or you can just leave it as it is and try to graph it via the intercepts method, which I think is much easier for this kind of problem. So the way to tell is if y and x are together, it's pretty much designed as the intercept method. So let's solve this for y as if x wasn't there at all. And then this is a real simple solving, y equals 2. That's a y-intercept. So it goes on the y-axis where y is 2. We also need to solve this for x, so we do the same thing only in reverse. This time we'll actually use the x term, -2x equals 10. And again, if I divide, x will be equal to -5. Which means on the x-axis, I need an intercept there, 1, 2, 3, 4. It's -5 over here. So I have the 2 points. I need to draw a line connecting them. I can tell where the line is going to intersect right over here. So I'm just going to start here and make myself a line that goes through these points best I can. So the graph then needs to figure out where they intersect, which it looks like right here. We'll have to give a good solid estimation if we can't tell. The coordinates look like they are -2 and up 1.2 or so. So -2, 1.2. Again, let's see that there went 2 to the left, and then up 1, plus just a little bit more, I'm estimating it to be 1.6. That's the final answer for this problem. All right, so this one is are the other two methods that we have. We have a plain y here, without an x in it, and then another one where we have some x's and y's involved. So let's deal with the easier of the two, which is the one with the plain y. Make this one a red line. What this says is that you need a horizontal line where y is 5. So we're going to go up here and go to 1, 2, 3, 4, 5. I'm going to need a horizontal line right here where y is 5. And that's all there is to that one. Nothing too difficult. Now we'll do this one. Okay, see, here I see a y here and an x here. They're on opposite sides of the equal sign. So it's really not ideal for the intercept method, which means you should probably figure out some other kind of method. In this case, I'm going to try to get y by itself and graph this like a slope-intercept form, y equals mx plus b kind of equation. So I'm going to start with the 2y minus 4 equals 4x. The first thing I do here is get rid of the minus 4, add 4 to both sides. That takes care of just having a 2y there now. Here, 4x and 4 are not like terms, so you can't really just add them. The best you can do is write 4x plus 4. And now all I need to do is get rid of the 2 next to the y, so I'm going to divide that away. Everything here gets divided by 2, so I get y equals 2x plus 2. That's what I'm actually going to graph. So this plus 2 is the b part of y equals mx plus b. That's a y-intercept. It goes on the y-axis where it would be 2. And then the other thing here is the slope. That should always be a fraction. So 2 over 1, that means from the first point we graphed up to and over 1. We have our 2 points, so we can draw a line. Again, I can see they're going to intersect up here, so I'm going to start here. And I have a line right there like that. So my intersecting point is right here. Looks to me like it's over about 1.5. And then it is up here over 1.5. 1, 2, 3, 4, 5. That would be the final one. So this one is just a combination problem where we have some more equations where you can try to adjust for the format. This one is definitely a y equals mx plus b kind of equation. I would say that what we should do with that is just think of it, I'm actually going to slide this down a little bit. This right here, the negative in front of the x, is really like a negative 1, but we do want it as a fraction, so not only is it negative 1x plus 3, but we also want this as a fraction, so I'm going to put it over 1. So I'm just going to graph that one now, just like I just did the last one. Put a 3 at the y-intercept, and then go down 1, right 1, down 1, right 1. So our point is right there. We have our 2 points thrown in. I'm going to draw a line through these points now. I'm going to extend this just a little bit. Okay, now let's take a look at the other equation. And you can see x and y are together, so it seems like it's ideally set up for x and y intercept method. This time, you're going to run into a little trouble because you have 6x equals 2. You divide, you get 2 over 6, which is 1/3, or 0.33. You really shouldn't round like that, but there's not much you can do. That decimal goes on forever. But this says that our x-intercept is at 0.33. So this is the trouble with graphing. If you go by this method, this is about where 0.33 is on the x-axis. If that whole block is 1. But again, that's not exactly accurate. The other one for y would be 2y equals 2. If I divide, you get y equals 1. That one's pretty easy. You get a 1 right there. So we need to draw our graph for this one. I'm going to start here. I can tell where they're going to intersect. I'm going to go this way. Like that. Now see, the trouble with graphing these are that, when you make an estimate like this point down here is, and I get a point right here, my question is whether or not that point is really the intersection, or maybe my graph is slightly off because of that bottom one. So this is the downfall of graphing, which is why in a minute you're going to learn how to do these algebraically. But that coordinate point, if I had to estimate, is probably to the left, negative 0.8, and up would be 3.8. So my guess is the solution to this is really negative 1, 4. And if I had to check it, I would look at this and say, if I put a negative 1 in here, I would get y equals 4. And if I did it here, I would get the correct answer. So if you did this on graph paper, sorry about that. If you did this on graph paper and you did it exactly accurately, you might get the correct answer here, but the actual answer to this should be negative 1, 4. And again, it just sort of shows the downfall of graphing and a little bit of human error that is always present. So let's actually learn to do these algebraically too, so that you don't need to make estimations like that. You can actually get exact answers this way. So your two methods for learning how to do these systems algebraically are one called substitution and the other called elimination. The substitution ones are problems where they're designed to have one equation substituted into the other. And the easiest thing to spot in these kind of problems are the types where you see the problem really ready for that, ready for the idea of substituting, which means that you have an equation where there's a variable by itself on one side of the equation. For instance, right here, I have a plain y with nothing else there. That's perfect for substitution. I have it again here in number 4. And down here also in number 6. This time it happens to be a plain x, but it doesn't matter. As long as you have a variable by itself, substitution like this is going to be really easy. So I'm going to take away those eraser marks because I don't need them. The highlighter marks. Sorry about that. So for substitution, I'm going to focus on number 1, 4, and 6 because those are the only ones here that have a lone variable like that. So for now, I can take number 2 out of here, number 3, and number 5. Okay, so let's take a look at number 1. In this case, what we're saying here, if you read this right, this says that y should be replaced with negative 2x plus 2. So that's exactly what we're going to do with it. We're going to take this and put this where the y was in the other equation. So that whole equation can be rewritten exactly as it was. I'm just going to leave a space where the y was, because in that space, I'm going to put all of this in parentheses. It goes in parentheses because you need to remember to actually distribute this, because it was 6 times y, and y is all of this, so you got to make sure you take that 6 times all of this stuff. So it's going to be 5x, but in here I'm going to get minus 12x plus 12 equals negative 9. I have to do a little bit of simplifying here. These two are like terms, I can combine them together. Now I want this plus 12 to go away, so I would subtract 12 from both sides. These would cancel. And over here, negative 9 plus negative 12, or negative 9 minus 12, would be negative 21. And I divide in one step. 2 negatives will give me a positive 3. So with my answer, I'm going to go back up to this first equation. And I'm going to look at the one that had a y by itself in it like this. I'm going to take my answer for x. I'm just thinking it's right here. Right? That's where I'm going to put it. Negative 6 plus 2 is negative 4. So y comes out to be negative 4. And you should write your final answer as a coordinate. 3 comma negative 4. So these other problems repeat the same process. It's just a matter of some different numbers, different signs here and there. The same basic idea. So I'm going to take this solution and just sort of take it out of the way so that we can look at the others. Okay, let's look at the middle one. We have y by itself again, and it tells me to take x minus 19 and put that where y is in the other equation. So 2x, even the minus sign stays there. But instead of where the y was, we'll replace that with x minus 19 in parentheses. Now you may think that it doesn't matter with the parentheses in this problem because you're not multiplying it by anything. But actually you are. This minus sign sort of implies a negative 1 here, which means everything in here gets multiplied by a negative 1. So the 2x will say that this is now negative x, and that double negative there makes that a positive 19 equals 27. So 2x minus 1x leaves me with x plus 19. And to get x by itself, I just subtract the 19 away. I get x equals 8. So once again, with my answer for x, I'm going to come back up here and just say, well, x is 8. So y equals 8 minus 19. That means y equals negative 11. Final answer is 8, negative 11. So you can see how with substitution, literally all the work is done in the finding the first variable. The second one is usually quite easy. All right, once again, I'm going to take this out of the way. Maybe I'll just move it over here for now. Let's work on the last substitution problem. This time, it's a little different. We have an x by itself, and it's telling us that x is y plus 1. That means that when I'm substituting, we're going to put this where the x was instead. So I have negative 3, but now, instead of x, I have y plus 1, and then I have plus 2y equals 11. I'm going to distribute here negative 3y and negative 3 plus 2y equals 11. I have to combine like terms. Negative 3y and positive 2y leaves me with negative 1y, or just negative y. Minus 3 equals 11. I would add 3 to both sides here. That leaves me with negative y equals 14. And so if negative y equals 14, positive y must equal negative 14. So there's our answer for y. Let's go back here. Knowing that y is negative 14 plus 1, that makes x negative 13. Final answer, negative 13 comma negative 14. Substitution problems are almost always the same idea. Just substituting one in either for x or for y. And usually they're set up and ready to go. Otherwise, you probably want to use a different method. So these three are the other methods. The three that we took away a little bit ago. This problem is set up for something called elimination. And it's usually pretty easy to tell. Because elimination requires you to add the two equations together to cancel out a variable. See here, the way to tell is x's, y's, equal signs, numbers, they're all in line, sort of waiting to be added. But the idea is that something has to cancel, so if you add these two together, you get 7x, that doesn't cancel. 6y and negative 3y added together also does not cancel, so this is not ready yet for the adding part. What I want to do is figure out some way to make something in this bottom cancel something in the top. And here is, I think, the best way to do that. This negative 3 could be turned into a negative 6 so that it would cancel this plus 6 up here. All I have to do is take this whole equation and multiply it by 2. I'm going to get 10x minus 6y equals 176. So really, you can actually still use this equation here if you want later on, but you really don't need it. So we can kind of take it away for now. I'm just going to look at the top one that we didn't do anything with and the new one. I just want to add them column by column. 2x plus 10x is 12x. 6y negative 6y, they cancel, which is what we wanted. Negative 8 and 176 is 158 added together. One step, divide by 12, and I get x equals 14. So I have x now. Now I need to go back and get y. For these problems, usually the second variable takes slightly more work than the first one. So I have this answer for x. I'm just going to go to this first equation and say, here's an x. I'll put 14 in there instead. And that gives me 28 plus 6y equals negative 8. So you can see that all I have to do now is simplify a little and I'll have my answer for y. I'll subtract 28 off of both sides, get rid of that, and that leaves me with negative 36. And when I divide, I get y equals negative 6. And so I have enough for my final answer, 14 for x, negative 6 for y. We're going to take a look at number 5 now. Actually, I'm going to wait. I'm going to look at number 2 first. And we'll come back to 5. So sort of keeping in mind what we just did in this last problem. If I look at this one, I see that I have x's, y's, equal signs, numbers, all nice and in line. So it really is set up for the elimination style. But neither of the x's cancel out or the y's cancel out. And the problem with this is, unlike over here where I could easily turn a 3 into a 6, I don't have that here. I can't really turn a 5 into an 8 or a 3 into a 5 to make it cancel. So I'm stuck in a little bit of a way here, other than to say I can multiply by a decimal, but you probably don't want to do that. It's probably a little bit easier to just multiply both equations to make it work for you. So what I would say is try to use as small numbers as possible. If you think about it, between 5 and 8, the smallest number that both of those numbers go into is 40, which means I have to turn them both into 40. It would work, but might not be the easiest or simplest way. Over here, both of these will go into 15. If I turn them both into 15, it'll work. So that's what I'm going to do. I'm going to plan to cancel the y's and try to make them both 15. So this top one, it's negative 3y now. I want it to be negative 15y. So I'm going to multiply it by 5. 25x minus 15y equals 210. The bottom one, I want this to be positive 15y, so I'm going to take this one and multiply it by 3. This is going to be 24x. Here's my plus 15y, and this is 84. So again, I really don't need these equations in the center anymore. Although if you want to use them to help you find your other missing variable, you can still use them if you'd like. So now that I have two that will cancel, I'm going to add them up. This is going to give me 49x. These two will cancel each other out, and I'll get 294 here. Again, one step dividing gives me x equals 6. Okay, because I try to avoid negatives, just in case I might make a small mistake, I'm going to take my x equals 6 answer and go to this green equation this time. Just because there's no negatives, I don't see too many potential for weird mistakes. I'm going to put this 6 where x was here. So if that's the case, it's 24 times 6, that is 144. And then I have plus 15y equals 84. So I would subtract away this 144 from both sides. That's going to give me 15y equals negative 60. And now I'll divide by 15, and I get y equals negative 4. So that would be my final answer for this one, 6, negative 4. So if you really pay attention to it, it really isn't much different than the first one, except that we have to make both equations work before we can start to solve by elimination. So it's just a matter of, thinking about it a little bit and saying, what can I do to make it cancel? I'm sure there are all sorts of different ways you can approach these problems, and if you did turn these x's into 40, you'd be okay. If you got these same answers, it must mean that whatever you did was mathematically correct. So you want to be careful that, when you do these, you keep everything accurate in terms of negatives and so on, and making sure you multiply everything in each equation by whatever it is you have to multiply by. Things like that are the common mistakes. All right, let's look at the last one here. I'm going to take out some of these solutions. So number 5. Pretty much the same exact problem as the other one with some different numbers in it. If you look at it like this, once again, I'm in a position where the 5 won't cancel the 6, and I can't turn a 5 into a 6. The 3 won't cancel the 7, and I can't really turn a 3 into a 7. So it's going to be one of those scenarios where I have to multiply them both. Once again, the smallest numbers these go into are 30. The smallest number that these go into is 21. So I'm going to go with that. I'm going to try to cancel the y's once again. This time, I'm going to make that negative 21, so I'm going to multiply by 7. That's going to give me 42x minus 21y equals negative 42. The bottom one, I'm going to turn it into 21 here also, but I need to multiply that by just 3. So I got negative 15x plus 21y equals 123. So once again, I do not need these middle ones anymore, unless you feel like using those for your final solving. So I'm going to combine these two equations together now, the top one and the bottom one. And I get 27x. I get these to cancel, and over here I get equals 81. I divide one step by find out that x equals 3. So to get y, again, you can pick either equation. I'm going to choose the bottom one. I see a positive here that's better for me. I don't know why. It just seems nice. So I'm going to put this 3 right here where x would be. And I would get negative 45 plus 21y equals 123. This is negative, so I would add 45 to both sides, and I'll get 21y equals 168. And if I divide by 21, I would get y equals 8. So my final answer for this one would be 3, 8. All right, these are the methods that you can use to solve linear systems of equations. Certainly they're not the only possible ways, but these are by far the most common ways, either graphing, substituting, or elimination. And the real skill behind it is deciding which one is the fastest way.